Hey everybody, welcome to Question Barn, episode 5. This is the show where we answer people's emails and have a lot of fun. Today on our show, we've got Geoffrey Lovelace. Hi, Geoffrey.
Hi.
He's not a usual titanium physicist, but he's actually a friend of Jocelyn's. And I was like, hey, Jocelyn, I want to talk about Interstellar. And she's like, no, we can't. Hold on. And then so she shoves Geoffrey in her.
Yes.
And so Geoffrey's going to talk. We're going to have fun. Hey, Geoffrey, introduce yourself.
So I'm Geoffrey Lovelace. I'm a professor at Cal State Fullerton, and my students and I like to use supercomputer simulations to smash black holes into each other and to see what kinds of waves of gravity get sent off from that. We want to help learn something new about the universe, not with light, but with a whole different kind of wave.
Yeah. So we've done episodes on gravitational wave. There's a couple of them. I think they're fairly early because it's a topic that we wanted to talk about. But yeah, we've look into the back episodes of Titanium Physicists. We talk about cool. Anyway, let's talk about the question.
Okay.
Yeah. Oh, actually, yeah. No. You know what? So the deal with Question Barn is usually we do small talk and we chat about our lives. But most of this episode is going to be chatting about a movie. So, all right, why don't I just read the email and then we'll talk about it. So This email was by a guy named Chris. He sends in and he goes, question for the barn. First off, you're not asking a barn questions. You're asking the rabbit, Barn the Bunny questions. Just FYI. So, question for the barn. Ben, thought it would be interesting to hear you and one of your titanium physicists discuss the science of Interstellar, separating theoretical quote-unquote fact from movie fiction. Thanks, Chris Morley. All right, Geoffrey. So let's talk about Interstellar. What did you think? Did you enjoy it?
I did. I think if I had to summarize my gut reaction in one word, never has time dilation been such a tearjerker.
Yeah.
I mean, I know the science. I've been teaching. I just taught special relativity in a class this term, and you know how it works. But actually seeing what it did to the characters, like what would really happen if you found yourself 7 or 20 years in the future, that's something. That's something that was new.
Oh, really?
And that I really liked to me.
Wow, that's amazing. So I feel like this tragedy of time dilation is ever present in relativity. I remember when I was first learning about the Schwarzschild metric, I was reading a preprint of somebody's book. Gosh, I forget who. My undergraduate thesis supervisor threw me a free preprint of somebody's book that he was supposed to proofread, and he was like, "Here, teach yourself relativity." And so I was reading it in the house, and everyone had gone, and I was reading about falling through the event horizon of a black hole, and it just struck me as wholly tragic. I was depressed for about a day and a half after that, and so ever since then, I've had no heart. I mean, it's just like I live with this. I'm like a Marvel supervillain. All I can do is mutter about the end of things, like Doctor Doom, right?
This was the first time that I'd seen this in a movie. I know that people have done things in sci-fi with time dilation and time travel, but nothing that I've seen really hit me the way this movie did.
This, like, the whole movie was based around the tragic sense of time dilation, and I think they did that really well.
Well, maybe one reason why it felt more visceral for me was because it was so accurate.
Yeah.
Because you can read. I haven't really read the whole thing, but you can read in the book about the science of the movie exactly what properties this black hole had and how they knew that that's what would create this time dilation effect without doing other stuff you don't want, like ripping the planets apart so that you couldn't have planets.
Is the book that detailed?
Yeah, it's pretty detailed.
Like Kip Thorne wrote it, right?
Yeah, that's right. He wrote it completely in secret.
Oh, really?
The story had to be embargoed until the movie came out.
No, Jocelyn said, "Are you Kip Thorne's student? Were you Kip Thorne's student?"
Yeah, I was one of Kip's last students in the PhD program. When I started moving into more computational stuff, I mean, Kip was my advisor, but he really was sort of my co-advisor. I worked with Harold Pfeiffer, who's now at University of Toronto mostly, and on the numerical relativity stuff.
Mm-hmm.
Lee Lindblom, I think he's at UCSD now.
Well, that's amazing. Okay, we should probably tell our listeners who Kip Thorne was.
Yeah.
Do you want to do it? Can I ad-lib an introduction to Kip Thorne? You should do it. You're a solid student. Do it.
Because it ties in a little bit of just my personal story about how I got into physics.
Yeah.
I first heard of black holes and thought they were very fascinating and mysterious when I was playing this Nintendo game called Star Voyager on the 8-bit Nintendo, and hardly anyone ever played it, as far as I know. But you could fall into a black hole, and I got very curious about it. There's this weird idea that once you go in, you can't come back, that I thought was very mysterious. But then later on, when I was, not really sure exactly what to do for a career, actually my mom worked at a community college library, and she was always getting books. And one book that she brought home was this new book that came out from Kip Thorne called Black Holes and Time Warps. Kip has, at that point already, had, been really, a leader in the field and mentored a lot of students and made a lot of discoveries. And the year I was born, he wrote this epic review paper on multipoles. And I never, but this is where I was introduced to him through his writing, but also to the idea, again, of black holes. But this time, even though there's no math in the book, it sort of doesn't dumb anything down. He's got a really crystal clear conceptual understanding and an intuitive understanding of what it all means. I'm just ad-libbing a bio. He's published like 100 papers. I couldn't begin to cover all of the stuff that he's done, but I think one thing that he's done that's before the movie, where he was more in the public eye, had to do with was when this book came out. That's how I ran into him, and I thought partway through the book, what does this guy do? Like, can you do this for a living? Well, that sounds awesome. That's what I would do.
Yeah. I'd say that Kip Thorne is one of the. First off, he's one of the. How would you put it? There's like a father of American relativity, right? John Wheeler.
John Wheeler, yeah.
And Kip Thorne's one of his students, or was one of his students, right?
Yeah. And so. Yeah. Sorry, I don't mean to keep.
No, go ahead.
I was going to say the introduction I just gave was like a really egocentric introduction. What I really say is Kip is this, he's this sort of father figure for the field. Like he's mentored not just a lot of students, but a lot of students who have gone on in their own right to have very successful and very influential careers.
Sure. Kip is the Kip. I've never met him. Dr. Thorne is the he's
he prefers Kip.
Well, maybe I'll meet him one day and then I can. Anyway, Kip Thorne. He's one of the father. He's like the driving force behind LIGO, right? Isn't he?
He's not the only person that was that was involved. He was certainly one of the original founders.
But I mean, as relativity in the 70s and 80s was flipping and flopping around various things, he was the guy who was saying, gravitational wave detector, let's build it.
Yes.
And he's not the only person or the only name or
Sorry, hello?
Yes, can you still hear me?
Hello, sorry, you just cut out for a second.
Okay.
Sorry about that. It's bad connection, maybe.
Okay, so Kip Thorne is fantastic, really, really important. I'd also say that he has a clarity of thought that's really, really rare in general relativity. His papers are always a real pleasure to read. They're always really well thought out, and he has really clear, say, thought experiments. Stephen Hawking does it too. Like, there are very few people who can just cut to the chase with relativity, and Kip Thorne's one of these guys. And so when he does foray into outreach, or say writing a novel for the general public, or writing a book for the general public, like the Time Warps book that you read. I read it too as an undergraduate. They're always very clear, accurate, without delving into jargon. An amazing thing. And so he consulted. He was the big scientific consultation on this movie.
Yeah.
And a lot of it is so right just because, it's got to have Kip Thorne's big thumbprint on it. Fantastic. I think, right?
Yeah, I think so. I think that there's a reason that he was given an executive producer credit. He had a big influence, and he was trying very hard to see that nothing known to be wrong was in the movie, and they mostly succeeded with maybe a couple of minor exceptions that I didn't even notice when I watched the movie.
Mm-hmm.
I'd say, yeah, so definitely bringing the conversation back to the movie. I think that yeah, he definitely had that influence. But he talks about this in the book a little bit about making of the movie. There was always this tension where he's the one saying, "Well, this is what we know. This is what we know, at least don't know to be wrong," and then Nolan and the film people come back and say, "Well, this is what we want."
Hey, Geoffrey got disconnected again.
The physics ideas without having to compromise anything. There was some stuff that was more speculative, but only a few things that I thought were so minor I didn't even notice that were just known to be wrong. I don't even remember what they were without going back and reading the book.
Yeah. So let's go through the movie as best it. How long ago did you watch the movie? It's been about.
I watched it when it came out.
Okay.
I watched it sort of. I didn't watch it early, but I saw it sort of opening night.
Okay. It's been about 2.5 weeks for me. So let's do our best to pick through. Why not try to walk through the plot of the movie as best we can remember? And
if you haven't already, there's a spoiler alert here.
Oh yeah, you guys don't listen to this past this thing because we're going to talk
about. Movie,
about.
Turn this off now and go watch the movie.
Yeah, or even watch the movie while listening to the podcast. Just go and turn on your cell phone. And blast the podcast while you're in the theater.
Okay, I don't endorse that. Yes. So let's see.
Well, let's start. Okay, so there's Earth, and it's in maybe a generation from now, right? Or two.
It was a little unclear to me how far in the future, but not that far.
No, less than 100 years. Within a generation or two of us. It's clear that people our age are John Lithgow's age in the movie, right? So it's been... People our age were happy, young professionals in the 20th century, and then there was some kind of cataclysm.
There was something that happened, so it's not our Earth. There's like a blight. And there's corn and not much else, and they're not even sure they can keep the corn growing much longer. And so, how are we gonna even have enough food to eat? Yeah,
there's actually an interesting point here. I want to see if you can remember. Okay, but quickly. A blight's just a fungus. It's a type of fungus. There was famously the potato blight in Ireland.
Right.
But humans only eat, in terms of grains, we take in most of our calories from only a handful of different grasses, right? I mean,
well, that's straying pretty far outside my expertise.
Yeah, I know. I mean, this is. But
just... my diet is maybe not so good. I eat a lot of microwave food because I don't know how to cook it. but in general, there's there aren't that many staple crops, I guess, that you think of as being mass produced.
Yeah.
There's like wheat and corn and, sugar, and then you start thinking, well, there's vegetables and...
Well, no. I mean, so there's wheat and corn and rice.
And rice, yeah, of course.
And then there's one or two others. And so the conceit of the movie is that there's some kind of super blight that's killed everything off, possibly all other it's killed everything off except for corn. So the only thing anybody can do...
Plants. It's a plant disease.
Yes, it's a plant disease. So essentially, almost everybody on Earth is starving to death, and everybody who isn't starving is put to work trying to farm corn.
Right.
And then, the main character of it goes and talks to bumps into some scientists. There's some ghost stuff at the start. Ghosts are talking to his daughter, and they get some coordinates, and they go talk, and they bump into NASA.
And they find the scientists there at what's left of NASA.
Yeah.
That's one other thing that I thought, it really hooked me into the movie. I was hooked on the first teaser trailer. I don't know if you saw that, but it just has Cooper, the main character from the movie, just saying over top of old NASA footage that, maybe we used to go to space, and now we've lost some of that, but maybe we can remember that we're still pioneers, and we can still go and learn things, and that was, yeah, and that was maybe I've sort of got away from you a bit, but that was something from near the beginning of the movie.
No, I thought that was interesting because that's the narrative printed on this. You have the main character whose drive is to go outwards. He always wants to be exploring, but because of all the stuff that happened, now he has to be a farmer. He kind of resents being a farmer.
And he even, he got Murph, his daughter, suspended because the propaganda at the school now is the moon landing didn't happen, and he wasn't going to play ball with that.
That was such a powerful scene.
I was freaked out by that.
Yeah.
Because it seemed so scary and so believable.
And so realistic. I mean, you had two people who were friendly and well-educated, essentially nodding and smiling and saying that the moon landing didn't happen. By the way, everybody, there is no question that the moon landing happened. Not only do we know that the moon landing happened, that those videos where people criticize the moon landing, not only are those videos stupid, but we've left a retroreflector on the moon. There's stuff up on the moon that we set up by hand that you can bounce stuff off.
I think the Big Bang Theory has the best demonstration of this.
Yeah, that was great. That was a fantastic episode.
Yeah.
I mean, I don't think I watched past that in that particular episode.
No, but that scene there was so great.
That one scene, look, there's something on the moon. So we have definitely...
Right.
Anybody questions you at all in the future, we left something on the moon. We left our wallet on the moon. You can still look up and see that we left something. So there's stuff on the moon. Okay, so moral of the story, he wants to leave. I thought that was really interesting because it's a really Western, American way of thinking. We have our frontier. We can't forget. We need to push the frontier.
Right.
Europe is full. We need to push out into these untrodden territories because it's well, that's an interesting way. I mean,
and it was interesting because that's a conceit of most. Maybe not most, I'm not an expert, but a lot of sci-fi movies are we're going to go and explore. Yeah. And this sci-fi movie starts with the opposite, that we're trying to survive. So we're going to turtle and try to farm and try to just barely stay alive. And you know what? We don't even need to try to preserve all the knowledge. There's a lot of times when there's an apocalypse that happens, somebody tries to save as much of what we know as they can. And in this case, they're doing the opposite with things like the moon landing. And they're you know what? That's not helpful knowledge. So we don't need to know that.
That's right. It was so fascinating because so I think that without a doubt, humans need to learn to live on the Earth better.
Sure.
Our society, Western society, incredibly inefficient, and we're inefficient for its own sake. So maybe we could cut that out. On the other hand, they're in a critical situation where literally everybody's going to die if there isn't more innovation. And instead of pushing this innovation, literally they're saying, well, we'll just keep our heads down and maybe something will work itself out.
Yeah. That's also unusual, I think.
It really was. It is a counterpoint because that's how people feel about space now. You literally say, "Hey, let's go to space." I mean, I love space. I would go to space in a sec. I mean, I want to bring my wife now with me, so and she probably doesn't want to go to space. But I would totally. Space is awesome, as far as I'm concerned. But a lot of people these days, they say no. They don't have this feeling that they want to move out. They say, well, no, we want to stay at home. I don't understand it, but this is why we don't get the same type of science fiction as we did, in the 60s, literature, science fiction, right?
Yeah.
The science fiction stories where people are moving out and essentially, Alpha Centauri is just the distance Europe is away right now. You just hop on a shuttle and go to another star system.
Yeah. So, but oh, sorry, go ahead.
No, well, yeah, you're saying that this is essentially this movie is in a conversation with the fact that we've moved away from this type of thinking.
I think so. And in the trailer where they're showing all these scenes of what NASA used to do, and now NASA is they just did a test flight, sort of where we were before we landed on the moon, and they're okay, we can survive the Van Allen belts with this craft, and now in a few years we'll try flying it around the moon without any people in it, and then maybe in mid 2020s we'll be able to land on the moon, although it's not clear if we're going to want to decide to do it.
Yeah.
So
it's an interesting perspective. So
yeah.
he talks to and then something crazy happens. They say that if the blight, so NASA predicts, and they have a room somewhere in NASA where they've got a blight that kills corn. So they had a broom closet full of dead corn, and they're like, "Oh, that's bad." So presumably,
and NASA's now an underground bunker, basically, is what's left of NASA.
Yeah, so they're working in this bunker. I guess they're building a space station in the bunker, but they're inside this bunker, and they've got a room full of dead corn. And then the main scientist says, this blight lives on nitrogen and not oxygen. So as soon as mankind starts starving, they're also going to start running out of air.
Yeah.
Did you catch that? Did that make any sense to you? Did I mishear that?
I'm not sure. I'm not sure about that. I mean, that might have been something in there. I knew it was a food thing, and I remember them saying something about suffocating because the blight was also it was disrupting the cycle between so there wouldn't be oxygen to breathe, but I don't remember the exact mechanism.
Is that all you were saying? That it would just kill all the plants on Earth?
I don't think so. I don't really remember off the top of my head.
Yeah,
but there was something there about some of them will suffocate and some of them will starve.
He's pretty much saying yes. Everybody on Earth is going to suffocate if this next stage of the blight comes out. Yeah, and it seemed very strange. I mean, I accepted it at the time. I was like, oh yeah, that makes sense. And then afterwards, when I was shopping, I think I was like, wait, nitrogen. If it breathes nitrogen, then we should be good.
I can almost guarantee there's an explanation for this in the science book, but I'm trying to I'm not going to go look anything up.
Yeah, no. Well, I mean, I might have misheard. Like I said,
but anyway, I thought it was interesting that they spent this much time on Earth and that it was different in all these ways we've been talking about. But of course, as the black hole scientist that I am, what I was really waiting for was for them to finally get out in space.
I know, right? You just hurry up, get. And then they do. It's interesting because a great deal of the movie spends in space, but they do drag their feet leaving Earth. And I think the reason they did that was they wanted you to feel alone in space, and they also wanted you to feel like you were missing out what was going on Earth. And so I think
feeling alone on Earth, because was so depopulated compared to today. Like they said, there aren't really any governments to speak of. It's these pockets of people, and they're not really fighting wars because they're more worried about all starving.
Mm-hmm. So yeah, it's I think it was for tone reasons.
Yeah,
because you get very lonely as soon as we go into space. I thought that was a really interesting thing.
Yeah, and I didn't mean to criticize it. I actually enjoyed that there was that much.
Well, I was like, get to the wormhole. Let's go to space.
There certainly was part of me I want to see the space stuff, but I didn't feel impatient. I was like, they're going to get there.
Yeah. No, they spent enough time in space that afterwards I don't feel ripped off by the amount of time they spent on Earth. It wasn't like
according to which character, how much time they spent in space.
So then finally he hey, hooray, he gets to go up into space, and they put him in a rocket, and then the rocket, he's piloting essentially a spaceship shuttle, a landing craft thing.
Yeah, so that was the weird thing.
They're so weird.
So when they launched in a Saturn-style rocket, like what we're probably going to use if we go back to the moon, like the plan is, or go to Mars or whatever. But then later on in the movie, when they explore the planets, like Miller's planet and the other planets and everything, then
it can just take off
they have
and
this
land.
Magical Star Trek shuttlecraft.
Yeah, pretty much.
Yeah,
it's realistic enough. So they get up into space, and then the little shuttlecraft docks with the ring. I thought that ring was great. So the overall interplanetary spaceship is this giant ring with the shuttle in the middle of it, and the ring spins to give them gravity.
Yeah, in a movie like this, that where the science is trying to be really accurate, there's just two little nitpicks that every sci-fi nerd knows about. There shouldn't be sound in space, and there shouldn't be gravity unless you're spinning or something.
Right. So they spin, and it's great because there's this spin up. In fact, there's a later spin. It becomes important to the plot that the thing is spinning. Right. But it's spinning, and it's great because you have this kind of spin up scene. Yeah. Like when it's spinning and you can't look out the window, gravity is outwards. Centrifugal force sticks you to the ground, right? And it's like gravity enough. But there's that scene where you're going from weightlessness to spinning up the ring, and you can see outside the window, and it's like a carnival ride, and everybody gets motion sickness.
Yeah, then they're like, I think I'm going to need some more motion sickness pills.
I love that. And then, so that I was pleased with that. And then their spaceship, they need to get out to Saturn where there's a wormhole. I thought the wormhole was doing a lot of gravitational lensing, all things considered.
It was, and I haven't studied the lensing nearly, especially for wormholes, that much. I mean, they had some model of the space-time that they needed so that the humans could get through it safely without, like you couldn't have a wormhole that was either going to close before a human could get through it, or that had tidal forces that were too strong. And there were some other things that they chose, other properties of the wormhole, I think, just to make it look cool.
Yeah. Yeah, but then so this is evidently one of those wormholes you make by stitching together two Schwarzschild geometries.
Okay.
I mean, you look at it lenses, right? So I mean, that's the common way you explain a wormhole too. Like it's the wormhole everybody learns how to make.
I wasn't sure if it was Schwarzschild.
Really?
Just watching it. I mean, there's another wormhole solution that's even simpler. It's like this is like flat space.
Yeah, but then you won't get any gravitational lensing.
Well, no, I don't know about that. There's still curvature at the throat, so the throat, if there's curvature, could still lens, I would think.
Yeah, but light coming in. Okay, so the reason you could tell there was a wormhole was there was a nice shot of the wormhole transiting Saturn. Right? So you saw this kind of black spot, the hole, and then also the colors of Saturn behind it kind of,
well, I guess
ringing.
Yeah, you're probably. I guess what you could say is it's got to be Schwarzschild on the outside because there were spheres, and you can say in general relativity you can show that every spherical vacuum space-time is Schwarzschild. So
yeah, but you don't. I mean, like you can just attach two vacuum solutions together, and in the wormhole throat, if you're really worried about it, you paste the walls with exotic energy.
And that's what what we're saying, something like that.
Yeah. And so
like as much exotic energy as they needed.
Yeah.
The people that built the wormhole.
Right. And there's no reason that it should have. I guess what I'm saying is that it lensed a lot of light. Like it was pretty lensy, I think.
Yeah, it was pretty lensy. And I think they
you'd think that if it was that heavy and also lensy, it would mess up Saturn. Saturn's got those rings. You can't just have something in orbit around Saturn that's as heavy as a planet and not muck up the rings right?
I don't know. I mean, I don't know what mass it was supposed to have.
Yeah.
And I mean, there certainly is curvature, but I don't know that all the curvature had to be in mass. Normally mass causes most of the curvature, but you can also cause curvature by other things, like in the Einstein equations, the stress-energy tensor, and that includes pressures and shears as well. And so it wasn't obvious to me. I mean, I'd have to go back. Just watching the movie, that was too much for me to think about. And I'd have to go back. I think there might be a discussion of this in the making of the science book. But just to me, it wasn't obvious to me that it had to be, there has to be some kind of energy causing all the curvature. If it's exotic energy, maybe it has negative mass density or something.
Yeah.
I don't know.
Yeah,
and so it wasn't. I see what you're saying, and that is something you might wonder about. Saturn's pretty massive. The wormhole was pretty small. If the size scale worked the same as a black hole, a wormhole that size is less massive than the sun. I don't know that it'd be less massive than Saturn. I don't know exactly how big it was supposed to be. The sun would be the size of a city if it were a black hole, and this was smaller than a city. So maybe its mass wasn't that bad. Like if the Earth were in orbit of Saturn, it would perturb its orbit, but maybe not enough that we would notice.
Yeah, but wouldn't it gank up its rings? I mean, those rings have like...
I think it would depend. I mean, Saturn... So what matters is the tidal forces, and so what matters is not just how strong the gravity is, but how it's changing, whether that's going to like start ripping apart the rings or not, how the gravitational force is varying with distance.
Right.
And... yeah, the Earth would exert some influence on the rings, but the Earth is much... See, this is why I'm feeling I'm a theorist. I don't have the number off the top.
Right.
How many Earth masses is Saturn, but it's so much less that I think it'd be a perturbation on the rings.
Yeah.
I don't think it'd be like, it would destroy the rings. And if this thing was the mass, well, a black hole, the mass of the Earth is like smaller than a golf ball. So it probably is more massive than the Earth if you're just going to use the Schwarzschild formula to ballpark it. But I don't, if it was just barely big enough for the ship to fit through, then maybe it's like, maybe roughly the mass of Saturn, maybe less, but it wouldn't have to be. It could have been somewhere between the Earth and Saturn, just based on how big it was. It wouldn't have had to have been as big as the Sun, let alone as a 10 solar mass black hole.
Sure. Yeah. No. Right. Okay. So anyway, whatever the case, they've got this nice wormhole MacGuffin.
Yeah.
And it was like, okay, you've seen, everybody who's seen this has seen this to the end of the movie, right?
Right.
So who put the wormhole there? It was future human civilization.
Yeah, it's a closed time-like curve.
It's a closed time-like curve. Yeah, it's self-consistent over. Okay, and then so they go through the wormhole. Incidentally, before we do that, their whole explanations of wormholes seems to be kind of based in all the theoretical explanations for these things seem to be based in higher dimension gravity. Like you looked at the equations on the board, that was like a 10-dimensional action, right?
T10x. Yeah.
Yeah.
Yeah, I wanted to freeze frame the movie and look at the board.
I know, right? I was like, what are those fields?
But I saw the 10 dimension. I'm like, okay, this is some sort of string theory, or we're a brain in the bulk or something. Mm-hmm. But I don't know. I took it to be the reason they did that was they wanted to be able to show you what it would look like to step out of flowing through time, to be able to look at time, sort of like stepping into a space-time diagram or something where you can see all the different events stacked up. And that's what was going on at the end of the movie.
Yeah.
As far as
Oh, I love that. Yeah.
Well, maybe I'm skipping ahead, but I think in order to get there, they had to employ this speculative, higher dimensions, because how else would you be able to visualize that?
Yeah.
If you're always confined to live inside of it, how could they show us the scene at the end?
Yeah, but wouldn't that mean that there's another, time dimension? How can you see time outside itself unless there's another...
Yes. So I think the usual theory is one time dimension and 10 space dimensions. But again, I'm not an expert on the string theory of it.
Right.
But there was the time dimension. I think there was the time dimension of the universe that Cooper was stepping outside of, but then he had to have his own local time too, or else there would be nothing sensible to watch.
Yeah.
And so I think there was a little pocket universe they created for him that had its own time separate from the rest of the time.
Right.
But I don't know. I thought he was hosed. He's going down the horizon. And
I know, right? Oh yeah, that was.
So, you don't come back, and then his ship inside the horizon, he ejects and
I know. I was like, don't leave your spaceship. It's made of sterner stuff than you. I mean, you're dead anyway, but this will give you a microsecond longer or something.
Yeah, and then he found, but it turns out, it's true you can't come back from a black hole horizon unless you have all this exotic energy. I think if you dump a bunch of exotic energy, negative mass into a black hole, you can shrink it. But also, if you can make wormholes, then you could always create some curvature to tunnel your way out of the black hole. I think.
That's right. In fact, yeah,
that sounds plausible to me. Anyway,
we're going to talk about that black hole because it's rotating and all sorts of great stuff.
Oh yeah, that was my favorite part.
I can't wait to I wish I knew how much of this was Kip Thorne saying no. Okay, here's your workaround, because somebody's read a textbook, at least whoever wrote this. It was elegant. I liked it. Anyway, okay, so you go through the wormhole. I loved it when they passed through the wormhole. I loved what it looked like. I loved looking at how the background stars just kind of shifted and rotated.
It was based on simulations. I wasn't part of the group. But there's a group at Cornell, both Gargantua, the black hole, and the wormhole. There's a group at Cornell that actually recently published a paper where for the first time you can take numerical spacetimes from simulations and do the lensing calculation on them in general and just see what would someone see if they saw two black holes merging, or if they saw a wormhole.
It was unbelievable. I started crying. I never cry.
Yeah.
I'm not a giant baby man, but you see things in your head for so many years, and then to see that people put so much work in that they want everybody else to see it too.
Yeah. So exactly. So Kip provided the equations. Now for Gargantua, the black hole, it's been known there's an analytic solution. I think there's an analytic solution for the lensing. Like you can, because you have an analytic solution for the space-time. In principle, you can just solve for all the geodesics.
Yeah.
But he then gave the equations to the rendering guys to do it numerically and do ray tracing, basically, at unprecedented resolution.
Yeah. Oh, that was gorgeous.
Yeah, and like I never would have expected the accretion disk to get lensed in that way, but that's what it does when you run the simulation, and that's completely consistent with what the Cornell group gets. The simulating extreme spacetimes lensing group is what they're called, and they get the same effect.
Yeah. Oh, it was amazing. It takes your breath away. I mean, you could. Somebody says, "Oh, you like there was nothing in it that was surprising, but it was still beautiful."
Yeah, the solution is known, but that doesn't mean you felt it.
This is
like
how
the same
people
with the time dilation.
Yeah. This is how people felt when they watched Lord of the Rings. You know, like the Lord of the Rings nerds.
Yeah,
when they first watched The Shire, and they're it's in my head. That's how I feel
about it, but like seeing it and feeling it, it just has this power. Now, everyone always says the book is better than the movie, but sometimes a movie can have this power, this visceral way to draw you in.
Yeah, this movie was
so. Yeah, so I loved Gargantua. My favorite thing to look at lately in the computer simulations that I work on with my students, with my collaborators, is black holes that are spinning really fast. And this black hole was spinning really fast, faster than we're even capable of simulating when we want to actually crash two of them together. It was like 99.99 and like 14.9% the speed of light or something like that.
Wait, which one was?
Not the speed of light, but like Gargantua was spinning with a spin of 0.9999 and like 14 nines.
Really?
Where one is like
Gargantua is almost an extremal black hole?
It's almost an extremal black hole.
That's amazing. Okay, but hold on. Hey everybody, let's pause and explain what an extremal black hole is. We can talk about the horizon structure of black holes in a little bit, because it's going to come up when we start talking about the singularities. The deal is that black holes, there are three different solutions for a spinning black hole. Okay,
right.
There's two classes, and then the boundary between them is its own class. So the idea is, if you spin a black hole past a certain speed, the event horizon around it disappears, and you end up with something called a naked singularity. So an extremal black hole is the boundary case where you're spinning it just fast enough that it only kind of has an event horizon.
Yeah. If you spin the black hole too fast, the centrifugal forces would rip up the horizon. Yeah. And we're pretty sure, but not 100% sure, that that's impossible, that you can't spin a black hole faster than the maximum.
Yeah.
Faster than one.
You can't take a black hole, pre-existing black hole, and spin it up past that.
Right.
Because, it's an energy game. You either, in doing so, it takes, getting it to spin faster once it's already spinning really fast, you either need a little bit more energy, and then it gets heavier, and so it doesn't become
and it's the spin over mass squared that matters.
Mm-hmm.
You have cosmic censorship. In numerical simulations, I tried making initial data when I was at Cornell, and I just, as a postdoc, and I cranked up the spin to try to make them spin faster than one. Mm-hmm. And so I said, here's a space-time, and let's make the inner boundaries horizons, and let's make them spin faster than one. And when you do that, you can solve the equations, but then this other horizon shows up outside of them that's bigger.
Yeah.
And so the spin over mass squared is less than one. And so, you can, there's all kinds of, that's just one little thing I saw. There's all kinds of things you can do, and there are some real experts in testing cosmic censorship. We don't know if it's true or not, but it's probably true.
Yeah.
But this one had to be so close to spinning as fast as possible, because
that's amazing.
They needed it to have the time dilation effect that was enough to be dramatic, and the tidal forces to be small enough that they'd create big waves but wouldn't destroy the planets.
I didn't know that about, because I thought they mentioned that it was a slowly spinning black hole at some point in
No,
the. Okay.
no, I don't think so. No, I did go and read this little bit from the book afterwards. So this isn't just me watching the movie and saying that's the only thing that's canonical or whatever. But yeah, the equations they solved for the black hole, it was spinning really, really close.
Oh, that's amazing. I didn't know that. Well, I mean, it's not like they told me that, but and it's not like the news would cover it.
They never even know how to say a black hole spinning extreme. They're like spin, and I even said it a bit ago, like fraction of the speed of light, and that's not really what it is.
Yeah,
it's sort of analogous.
Yeah, that's great. Okay.
Yeah, I was a big fan of the black hole.
So there's a neat divide in the movie where they pass through the black hole, and I want to point this out because it has to do with time and also science fiction. So before, there's the main character, Cooper. He's really sad. He's left Earth. His daughter's mad at him. He's in space, and you get this horrible sense of loneliness, right? Everything on Earth is nice, warm, earthy.
Yeah.
Everything's green and brown and green and good, right? And then you go into space, and everything's dark and plasticky and kind of gross looking. And then you have to like live inside of a wet plastic bag.
Yeah.
for like 8 months. And the spaceship, to get out to Saturn, it takes, what, 2 years? Something like that.
Yeah, something like that.
And then in addition to that, of course, like regular Earth-made machines do, you can't make your spaceship go fast enough on its own using its own fuel, so it slingshots around Mars or something on the way to get there. They mentioned that they need to gravitational slingshot to get out there, which is fine. Okay. Takes 2 years to get out there, and everything's dark and gross, and the stars are dim, and everything is so lonely. You feel at the very edge of nowhere.
Yeah.
And then you pass through the wormhole, and the stars get bright, and everything gets exciting, and it no longer takes 2 years of plastic bag living to get anywhere.
Yeah, these three planets were all orbiting the black hole, so it was like went to one solar system, and the planets were just in different orbits.
So, but there were like 5 planets, quote unquote, within reach. Were they implying that all 5 planets were around the black hole?
I think so.
Because I thought that they said that some of them were orbiting, but not all. And also they mentioned that some were near the event horizon, which I was like, what?
Yeah, some were closer than others. The ones closer have the stronger time dilation effect.
Right. So they were saying that the first planet they visited... So you're thinking, and I have no reason... Because this is the only thing that even marginally makes sense, is that all of the planets were around the black hole.
And they were close enough that you could actually move between them more easily than you can move between the planets.
Because that makes...
the solar system.
That makes so much... Because I was like, they mentioned that some were... In sometimes, when they'd be talking about a planet, they would mention the black hole more emphatically than when they were talking about other planets. And so... they never in the movie show you a diagram of where all the planets are. You just hear them conversing about it. And so I was like, are some not around the black hole? Like, are some around a nearby star?
No, I think this black hole and its accretion disk were like the sun. Like that's what was radiating the energy for the planets.
Right.
At least that's how I took it. No, I don't know. I mean, I think they might have said something. Did they say something about a neutron star as well in there?
They did mention. Yeah, they mentioned a neutron star around the black hole.
Yeah. So.
I thought that was I was like, oh yeah, let's just swing around the neutron star to get there faster.
Yeah. So maybe that's not true. Maybe it's not just the mass falling into the black hole. Maybe the neutron star also is kind of like the sun, but maybe they were close enough together. All I know is remember is when you looked up in the sky, you were seeing the black hole in the sky.
Yeah. Well, they'd show you the black hole, and they wouldn't show you any other star.
Yeah.
But you would be in planets where it looked like it was a sunny day. Well, no, hold on. It looked like the sun was out, but it wasn't.
Yeah.
I mean, you'd never see the sun. It was always overcast, but...
Yeah. Okay. I actually have to run in like another probably 10 minutes at the most.
Oh, no. Okay. Well, that's...
So I thought it was going to be about half an hour. We've been having a good chat, but it's been... Oh,
man. I love this movie so much, apparently.
Yeah. So there were a couple other things I was wondering about. Like, did you see it coming that the guy they found was going to be crazy?
Yes.
Try to kill them all?
Of course. You saw that coming, right?
Yeah, when the snarky robot is like, yeah, your trust setting's higher than mine, apparently. Like, Yeah, I felt insulted too because I didn't see it coming until he's like menacingly walking towards the main character, and
Yeah,
it's like really too late.
no. When the sleeping spaceman woke up and started
Yeah.
crying, I was like, and acting like he'd done something tragic, I was like,
Yeah.
there's nothing here for them. He has just done something really selfish.
They've been building him up as this big hero, so you probably should have been able to see that coming.
Yeah.
I guess I was so caught up with the black hole and everything.
Okay, well, let's talk about the black hole just quickly, because they do something really fun to get to the other planet fast enough. Cooper drops him. They go really close to the edge of the black hole, and Cooper drops his stuff in.
Yeah.
Right?
Right. Like I think he dropped the robot inside of one.
Yeah, well, the idea was they dropped the robot inside it, but then he himself drops in another one of the shuttles.
Right.
Now, that was that, who's it named after? It's not named after Eddington. What? There's a maneuver where you, if you're inside the ergo surface of a spinning black hole.
Is that the Penrose process?
Yeah, that's it. It's the Penrose process.
And you extract some of the black hole's rotational energy.
Yeah,
and so that's what they were supposed to be doing.
That's what they were doing.
Yeah.
So people were like, "Hey, why are they moving faster? Why would you want to drop this weight?" Because they were only dropping the weight. They weren't like projecting everything off. It's a process called the Penrose process. We actually talk about it in a different episode of the podcast in the mid-30s, people who want to listen to it. But yeah, so they what amazed me about this movie is how much general relativity was in it that they didn't even spend any time explaining.
They're just like, we're going to do that. And and I'm not even sure that I picked up on that the first time. When I hear it described, I recognize what it is.
Yeah.
But yeah, there were lots and lots of little things like that.
Mm-hmm. Actually, one thing that was weird was one person went down to the planet and then beamed out that it was okay to live on. It was the first planet they went to.
Right.
Why wasn't... So, and then the idea was that they had died immediately after landing, but time dilation was so strong on that first planet that, it took several years for that. They hadn't received the notice that the person was dead yet. Wouldn't the signal going back to the shuttle be really, really, really redshifted if there was that much time dilation?
Yeah.
Yeah. I'm like, well, wouldn't you know based on, like, you wouldn't even receive the message. It would be like deep, deep, deep radio.
Yeah. Yeah. Maybe they had something to, like, hit it with some kind of frequency transformation to bring it back.
But wouldn't the fact that you needed to do this transformation indicate that,
Yes. And all I could say about that is I think it was clear that on several points the humans were not behaving perfectly. They were like, in a real NASA mission, you would have mission control telling you what to do the whole step of the way, and you'd have an army of experts behind you.
Uh-huh.
And here, NASA doesn't have that anymore. They've just got a few astronauts, and they're like winging it because that expertise, that army of expertise, just isn't there anymore. And I think that's how I rationalize all the strange things they decided to do. Like, they're just not the NASA that we have.
Right.
And they just don't have all that expertise, and sometimes they just make the wrong decision.
Yeah. Yeah, I think
Not that our NASA never makes the wrong decision, but it's just so easy for them to make the wrong decision.
Right. I think that was emphasized on several cases. Yeah. But even then I was like, how does the physics work? You need to engineer in a thing that, receives the signal and corrects for it if it's going to do that.
I was confused about that too. I don't know what the movie's real explanation for it is.
Yeah, but that's okay. I mean, artistic license. And then there was that big wave. What was that wave about?
Was just tides. The planet was not so close that the black hole's tides would rip it apart, but the tides are way stronger than the moon exerts on the Earth's oceans.
So it's a really tall tide, and then is it just that that planet was spinning really fast? So you'd pass through one of the tide bumps every 2 hours?
I don't know. I don't know if it was that or if it was that because there's a big tide that can kick up like atmosphere and wind-driven waves too. I don't know. I don't know how that would work.
I've been mulling over wave mechanics, and I'm like, wouldn't a really big wave dampen down? I mean, like, what if it was the way there were like 8 waves over the surface of the planet resonating with the orbit? And I was like, resonating with the tide. The tide.
You'd have to know how the resonance would work. I guess.
I don't know.
That's getting. Yeah.
Yeah. Yeah, I think I've heard other people complain about it online. I don't know. I thought it was fun. Big old wave.
I mean, it's certainly true that you'll have a big difference between high tide and low tide on a planet like that. And maybe they made it spin fast. Maybe that does the fluid when it has those kinds of tidal forces on it. Maybe that can, the fluid can. It doesn't all happen instantaneously. There's some viscosity and friction, and maybe somehow that can kick up some waves besides the high tide and low tide. What I was confused by was, what are they standing on?
Yeah.
Like walking around. Like, is the water like only a couple inches deep?
I think it was.
There isn't a tide?
Yeah.
Because that seemed weird.
Yeah, I think that's the conceit. It's a nice spherical planet with two big waves on it. Maybe spinning super fast or something. But you'd think they would know from space. I mean, those are huge. Anyway.
Those were,
Anyway, it was one of those things where it was like, I'm not sure if that makes sense anyway. What were there any other big sciencey things on it? I thought...
There was the whole big thing at the end about stepping out into the bulk in his little pocket universe.
What were your impressions? Was that... I mean, okay, compare this to, say, 2001 Space Odyssey, where it's just like, hey, at the end of the movie, everybody does some LSD.
I thought it was... Yeah, I thought this one was... I liked it better. I thought 2001 was creepy, and not necessarily in a good way. I mean, it's a classic or whatever, but I think that movie is a lot more disturbing to watch. Like, in spite of all the bad stuff that's happening, Interstellar is really optimistic.
Yeah.
And like Bowman doesn't come back from the Stargate in 2001, but Cooper does come back from the black hole, even though you'd think that'd be impossible. Mm-hmm. And it wasn't meant to be as disturbing, I think. I mean, it's weird, but you pretty quickly realize, oh, he's just looking at different slices of time.
Yeah.
And he's going to influence it to save everything. And so I didn't completely get everything they were trying to show you, but at the time, but you could sort of figure out, oh, up there is supposed to, because if you spent your life looking at space-time diagrams, you're like, okay, up there is supposed to be later, and down there is supposed to be earlier.
Right.
And they're explaining it by saying he's in this pocket universe out in the bulk or whatever.
Yeah.
And somehow he can exert an influence through, I guess they were supposed to be gravitational waves or something, but like through curvature, through higher dimensional gravitational waves or something. Some information through the higher dimensional space-time stuff.
Yeah, he's plucking the world lines of the different objects. And it's I thought that was really neat, because so rarely do you get essentially space-time diagrams.
Yeah, and maybe that's what made it easier to sort of try to picture, because we're used to like slicing up space-time into a bunch of different times.
Yeah.
A bunch of different spaces at different times. And if you've never seen that before, that last scene must have looked really, really trippy.
Yeah, it was such a great recognition. I mean, it looks so pyramid, crystal, everything is weird, And then you see the fact that he's going to send a message through, essentially by tweaking the world line of the small hand of the watch, because he can barely affect anything, but what weighs less than the small hand of the watch? What's more meaningful to the theme of time and communication than him tweaking it? And essentially what you see is this long line of light that represents the world line, where the hand of this watch is going to be over time, and he pokes it. And then, like, that's where we found out the message to Murph was real. And when I first saw it at the beginning, I was like, oh, she's really upset, and that's why she's saying that the ghost said that he was supposed to stay. But it turns out he was telling himself to stay for real. That's right. I thought that was so heartbreaking, because he's essentially appealing to himself in the past. Stay. But on the other hand, you're in a movie and you're watching this and you go, oh, he's going to do something. Something's going to work out. Like, because Merv's in the future. And he's he can interact with her, and you're like, well, something. You can see how things are. So you're not as heartbroken as him, but you can see how he's essentially feeling nothing but horrible regret. I didn't understand why he wasn't crushed. Actually, there's one great thing: spinning black holes. You don't hit the singularity necessarily.
Well, no one really knows what happens inside. There's actually a lot of research in numerical relativity about that. The Kerr black hole has a singularity that you can avoid, but the inside isn't stable to perturbations.
Right.
So what really happens inside, if you actually try to collapse something and simulate it on the computer, it's not clear. People have looked at, like, I don't remember the authors off the top of my head, but there are these papers that say that, well, there are different kinds of singularities you might get, and they might be weaker or stronger. Like maybe the curvature is infinite, but the tidal gravity wouldn't be.
Yeah.
But
there's a singularity along the inner horizon of the Kerr black hole.
But in a real black hole, it's not going to be Kerr. It's going to be something different. And what the form the singularity takes, I don't know that anybody knows yet. But I thought it was pretty clear that once he ended up in the black hole, he never saw the singularity. He went into this little. He left the four-dimensional space-time. Space-time.
His progeny plucked him out of space-time and put him in a bubble. But the robot somehow interacted with his.
The robots were awesome. I was a little worried about robots in a realistic movie, but they were awesome.
Yeah, they were. I liked how mean they were.
They were mean. They were funny, and they were believable. Like they didn't try to be more humanoid than they needed to be. Like they could have a little water wheel thing when they needed to swim and stuff like that. And
yeah. I like the robots. In a lot of the things, I was like, why not get the robot to do it? Like, they're like running out to the thing. I was like, why didn't you send the robot out? That robot can move fast. And so when they did, and the robot rescued the girl, I was like, right. Why didn't you do that at the start?
Yeah, I think they all made bad decisions. That's the various points in the movie. That's part of what created the drama.
It's true. It was a crummy crew. Well, I guess you've got to go now, don't you?
Yeah, it's been. I really wanted to squeeze it in, and we've been going twice as long as I thought I had today.
Jeffrey, this was wonderful.
Yeah, thanks for asking me on the show. I'd love to come on the bigger form of the show.
We'll have you on a proper titanium physicist podcast in the future, definitely. This was wonderful, and everybody wanted to hear two relativists gab about the relativity of this movie. They got what they want. Happy Christmas, everybody, or Happy New Year's birthday, I guess. Yeah, thank you, Jeffrey. Thank you, everybody. Okay. See you later.
Bye.
All right, see you, Jeffrey. Bye.